Hey there, folks. Welcome to the Chapter 4, Section 5, and Section 6 test review. I'm going to do everything on the we do side, obviously. Numbers 1, 2, and 3 are over Section 4.5, and 4, 5, and 6 over Section 4.6, just for what it's worth if you want to go back and revisit those videos. So 4.5, the objective was to solve a system of equations where one or maybe even both of them are quadratic functions. So I'm going to solve this one by hand, and then I'll do the other two in the graphing calculator. So solving it by hand, I'm going to do substitution. I see that this bottom equation is in y equals form, so I can substitute that into the other equation. So I'll just write out 5x minus 6 equals, and then it normally says y plus 5x squared, but I'm going to plug in negative 3x minus 3 for y plus 5x squared. And so typically when I plug it in, I have parentheses, but you actually don't need the parentheses here because there's nothing to distribute. There's no minus sign to distribute or a number by the y. So this is good to write as is. So yeah, what you want to do now is just get everything over to one side. So let's just get these 5x and the 6 over on the right side. So I can minus 5x under the 3x, and then I can add 6 under the 3. And so I'll write things in order this time though. So 5x squared should be up front, then minus 8x from minus 3x minus 5x, and then negative 3 plus 6 is 3, so equals 0. And so now we're going to factor this. So because there's a number in front of the x squared, I got to multiply it to the end number. So the factors of 5 times 3, that's 15. The factors of 15 that add up to the middle number of negative 8. And that will be negative 5 and negative 3. Negative 5 times negative 3 is 15. Negative 5 plus negative 3 is negative 8. So I'm going to write down x minus 5 times x minus 3 equals 0. Okay, so because we multiplied our 5 to the back, now I have to divide it out. So you multiply the 5 to the back to get your factors, and now you're kind of undoing it, so to speak. So x minus 5 over 5 turns into x minus 1, and then x minus 3 over 5, if it makes a fraction, send the fraction up front, so 5x minus 3 equals 0. All right, and so to solve this, you set each parentheses equal to 0, or you just flip the signs. That's kind of the quicker way of going about it. So 1 minus 1 equals 0, so x equals 1. And then if you want to do this one quickly, just look at the previous step. It would be positive 3 over 5. If you plugged in 3 over 5 into 5x minus 3 equals 0, you'd get 0. 5 times 3 over 5 minus 3 equals 0. So these are my two x answers, but I need to find the two y answers as well. So the first equation, or the original equation, I should say, the second one, y equals negative 3x minus 3, it's set equal to y. So all I have to do is plug these values in and figure out the y value. So over here where I have space, y equals negative 3x minus 3, that's going to be negative 6. So, because that's negative 3 minus 3, right? So, so when I plug in 1, I get negative 6. And then I just need to plug in the other one, y equals negative 3 times 3 over 5 minus 3. And that's going to equal negative 24 over 5. Here, I'll draw this. All right, so that means my other answer is 3 over 5, comma, negative 24 over 5. And that would be officially my two answers. I need to get the x and the y. So that's number 1, solving it by hand. So number 2 is the same kind of problem, except I say solve using the graphing calculator. Here, you just need to get them into y equals form. And then once they're in y equals, you're good to graph them. So like this second equation, if I just add 2x to the other side, I wouldn't combine it with the -4 because it doesn't have an x with it. So I'm just going to write y equals, and now it's positive 2x minus 4. And that second one is in y equals form. So that one's good to graph. So now let's just work with this, talk about the top equation. So 2x squared plus 4x minus y equals -3. I need to get this in y equals, so if I get this to the other side and then I get this -3 over there, I'll get it in y equals. So I'll add y to the other side. And so that gets rid of that, but I need to get rid of that +3 as well because I need it to be over there. So don't combine anything on the left side. They're all different terms. 2x squared cannot combine with 4x because it doesn't have an x squared with it, it just has an x. And then the 3 just gets tacked on at the end, +3, because it doesn't have any letters. So now it equals y. So I have my two equations. So if you're using the TI Inspire, graph these without the y equals. Just type in 2x minus 4 into a graph page, and then 2x squared plus 4x plus 3 into line 2 on the graph, and then do menu 6, 4 to see where they intersect. So using the Desmos app, I can show you a picture of the two graphs. And you see here that they don't actually intersect. So if you do menu 6, 4, the calculator will say error, no intersection found. So if there's no intersection at all, we say the answer is no solution. And that's pretty much everything there is to say about number 2A. So let's move on to 3A, shall we? So here I'm going to solve using the graphing calculator again. So if I just get these two terms over to the other side, they're good to graph. So I can add 10x squared to both sides. That'll cancel it there. And then I'll tack on a plus 10x squared here. And then I can minus 5x squared on the other side. Just tack it on there. And so let's write these in standard form, meaning write everything in order. So I have y equals 10x squared minus 80x plus 155. Graph that without the y equals. And then graph y equals negative 5x squared plus 40x minus 85. Again, type it in without the y equals because it's already in y equals form in the graphing calculator. Although it says f of x, but that's interchangeable with y. So graph it, then do menu 6, 4, and you should see one intersection when you do menu 6, 4, and that's at 4, negative 5. So that's the answer to number 3. So on 4A, we're now in section 4.6. So we need to plug all these points in to the inequality that's given to determine if it exists in the solution set. So if you were to graph this, you would have a shaded graph, and do those points fall in the shaded area of the graph? So basically all you need to do is plug these in for x and y and give me a true or false statement. So I'm going to just label every point xy, xy, and then I'll just set it all up. So I'm looking at y is less than 3x squared minus 12x plus 14. So I'm going to replace y with negative 4, less than or equal to 3x squared, 0 squared, minus 12x, so minus 12 times 0, plus 14. You can type this all into the calculator. You would do control equals to get that inequality sign, or you can just evaluate it this side, type in this side all at once. That's going to equal 14. So, and then just reason it out yourself. Is -4 less than or equal to 14? Yes, it is. That's a true statement. So if it's true, then yes, it's part of the solution set. Okay? So I'll do the same thing with the other two. So 5 less than or equal to 3 times 2 squared minus 12 times 2 plus 14. So again, type this all into the calculator if you're using the TI Inspire. If not, then just type all this in. You're going to get 2. So is 5 less than or equal to 2? No, it is not. That is a false statement. So this point is not in the solution set. So the last point, 514, I'm going to write down 14 less than or equal to 3 times 5 squared minus 12 times 5 plus 14. So if you were to type in the whole right side, it would say 14 is less than or equal to 29, which is a true statement. So that third point is also in the solution set. And that's really all there is to that section right there. So also on 4.6 was solving inequalities algebraically. So we're going to get everything to one side, and then we're going to factor it. So I'm going to add 28 over, and I'm going to get x squared minus 11x plus 28 is greater than 0. So I'm going to factor this. What are my factors of 28 that add up to negative 11? All right, so the third number, 28, the factors of 28 that add to the middle number, negative 11. And that will be negative 7 and negative 4. Negative 7 plus negative 4 is negative 11. Negative 7 times negative 4 is positive 28. So I'm going to write x minus 7 times x minus 4 is greater than 0. So you would take these and set them equal to 0, right? And so you'd get x equals 7, and then x minus 4 equals 0, you would get x equals 4. But these are your boundary points. They're not the final answer. They're not the final answer because we had, it was greater than or equal to. We had an inequality sign. So we need to determine if x is greater than or equal to 7 or less than or equal to 7, and same question for the 4. So what I do is I draw a number line. I plot both of them on the number line, 4 and 7. And then I'll use a closed dot since it was an underlined inequality symbol. And then I'm going to pick a number that's in between 4 and 7, so like 5 or 6. So I'll just pick 5. And so what we're going to do is we're going to test the number 5 into our original equation here. So does 5 squared minus 11 times 5, is that greater than or equal to negative 28? Typing this into the calculator, that's 25 minus 55, that's negative 30. Or that's doing it in my head, I didn't type it in the calculator. Negative 30 greater than or equal to negative 28, that's a false statement. So because that's a false statement, we go back to our number line, and we don't shade in the middle, we shade on the ends. Okay, and so if you're shading on the ends, that tells you that you're going to have an or statement. X is less than or equal to 4, or x is greater than or equal to 7. And if you get confused with that stuff, the shading points to which way the arrow is pointing. So it's shading to the left of 4, so the inequality sign is pointing to the left of 4. The arrow is going to the right of 7, so the inequality sign is pointing to the right. So that's how you get the final answer for a problem like that, okay? Okay, 6a, I'm going to solve algebraically as well. So it's going to be the same thing. I'm going to get everything to one side, And so I'm going to have 3x squared minus 13x plus 10 is less than 0. Only there's an additional step now because I have a number in front of the x squared. So that means to factor it, I have to multiply it to the back. So what are my factors of 30? 3 times 10 is 30. That add up to the middle number of negative 13. That will be negative 10 and negative 3. So x minus 10 times x minus 3 is less than 0. And so because we multiplied a number to the back, now we have to divide it out. And so if it makes a fraction, swing it up front. So 3x minus 10. And then 3 over 3 makes 1, so x minus 1 is less than 0. So now we've properly factored 3x squared minus 13x plus 10 is less than 0 into this. And so if I'm going to solve it, each time you see the x, set it equal to 0, right? And so it's basically flipping the sign like when it's just an x. So x is equal to 1 on this one. And then on the other one, if you want to do it real quick, just look at the previous step. Positive 10 over 3 is what the answer to this second one is, or the first one I wrote down, but the second one I'm talking about. But yeah, those are my two endpoints. So again, I'm going to just draw a number line, and I'm going to put, let's say 1 is smaller than 10 over 3. 10 over 3 is 3.3 continued. So these have open circles because they are, the symbol was not underlined. It was strictly less than. And so I'm going to test the number between 1 and 3.3 forever, continued. So that's like a 2. You could plug in 1.25, you could plug in 2, 2.5, 3, whatever, as long as it's in between 1 and 3.3. So I'm going to plug in the number 2. And so it's 3x squared, so 3 times 2 squared minus 13 times 2, is that less than negative 10? So this ends up saying negative 14 less than negative 10. Is that a true statement? Yes, it is. So because that's true, I go back to my number line and I just shade it in the middle. And because you shade it in the middle, you have 1 is less than x, less than 10 over 3. Basically x goes in between the two numbers. And anytime you write a compound inequality, the signs point to the left. They'll never point to the right on a compound inequality. If they're pointing to the right, it should be rewritten as an or statement like that. So yeah, they'll always be pointing to the left. So that's going to wrap it up for the review. So thank you for watching and good luck on the test. Bye.